All right, let's jump right in. Welcome to today's Explainer, where we're tackling what is arguably the most profound mystery in human history, the search for alien life. Now, just to be clear up front, scientists haven't found definitive alien life yet, but they have found some genuinely intriguing clues floating around out there in the cosmos. Here's the thing, though. The real question we need to be asking isn't just whether we have evidence. The much bigger, much harder question is knowing what kind of evidence would actually count as undeniable scientific proof. So today, we're going to learn how to think exactly like scientists, cut through all those sensational headlines you see on your feed, and understand what it will actually take to prove we aren't alone.
Because honestly, this question changes everything. Just establish the stakes in your mind for a second. If life exists beyond Earth, even if it's just tiny, microscopic bugs on some distant moon, it means life isn't just a rare freak accident tied only to our planet. It means the universe could literally be teeming with it. But if it doesn't exist anywhere else, well then Earth is a far more unusual cosmic anomaly than we ever dared to think. This isn't just science fiction anymore. It's a fundamental question about how life starts, where it can survive, and what actually counts as evidence when the thing you're desperately searching for is millions of miles away and completely hidden from view.
And that really illustrates the core challenge scientists are facing here. Think of it like trying to figure out if a massive sports field was watered, but the sun is already set. You can't actually see the water falling from the sprinklers anymore. But what you can do is search for the wet soil and the muddy footprints left behind. Alien life science works exactly the same way. We are very rarely going to just see the alien itself waving at a telescope. Instead, we're painstakingly searching for the hidden footprints it leaves behind in its environment.
So, moving on to Section 1, decoding the clues, what actually counts as evidence. Real evidence isn't just finding something weird. It's a clue that actively rules out alternative explanations. Think back to our wet ground analogy for a second. Wet ground could mean it rained, sure, but it could also mean a pipe burst or someone just spilled their giant iced tea. A clue only becomes strong evidence when all those other non-living explanations start to fail. So how do scientists actually escalate a random curiosity into a massive discovery? Well, it happens in 3 distinct steps. Step 1 is an interesting signal. This is something unusual or rare. It's definitely worth investigating, but let's be real, it's far from proof. Step 2 is a stronger clue. This is a pattern that fits life a bit better than just random, chaotic chemistry, but alternative explanations definitely still exist. Finally, step 3 is convincing evidence. This is the absolute gold standard. This happens when non-living explanations have been rigorously tested and weakened, and multiple, totally independent clues all point in the exact same direction. To actually reach that level of convincing evidence, we have to understand a really key distinction: direct versus indirect evidence. Now, direct evidence is the absolute dream. It's the thing itself. Imagine a rover digging up an actual squirming living cell on another world. That gives the clearest support possible. But the reality? Most alien life evidence is indirect. Indirect evidence is just a sign, a trace, or a pattern that merely points to the thing, kind of like finding an unusual mixture of gases in a planet's atmosphere. It suggests a really cool possibility, but it requires a massive amount of human interpretation.
And indirect evidence isn't bad. In fact, when we're looking at distant exoplanets, it's practically all we have. But you have to be so careful. It's literally like hearing a thumping sound through your apartment wall. You might be tapping your foot to what you think is a heavy baseline, only to realize, nope, it's just the neighbor's washing machine on the spin cycle. When we're dealing with indirect evidence from faint light, distant chemistry, and cosmic patterns, context and extreme caution are absolutely everything.
Which brings us to Section 2, where to look harder. Specifically, we're talking about atmospheres and habitable environments. The most famous clues usually lie in planetary atmospheres, which basically act like a planet's chemical skin. Finding a chemical imbalance, like, say, finding oxygen and methane existing together when they should naturally destroy each other, strongly suggests something active and energetic is happening down below. But here comes the heavy scientific caution. Finding these gases is thrilling, no doubt about it. Actually, wait, let's go back to our washing machine analogy. Volcanoes, lightning strikes, intense UV light from the host star, all of these can produce deeply surprising, imbalanced atmospheres too. A chemical imbalance is not automatically biology. It's an interesting signal, maybe a stronger clue, but those mundane, non-living sources absolutely must be ruled out first. And that perfectly tees up clue number 2, habitable environments. Sometimes the strongest evidence isn't a direct sign of life at all, but rather proof that the conditions for life might just exist there. Life as we know it needs a solvent like water. It needs energy, useful chemical elements, and a bit of stability.
We actually see prime suspects right here in our own solar system. Mars has ancient water channels. Jupiter's moon Europa has a vast ocean hiding beneath a shell of ice. Saturn's moon Enceladus literally erupts massive water vapor plumes out into space. But remember this, habitability is not proof, it's permission. It simply tells scientists where they have permission to look a whole lot harder.
Section 3. Ingredients versus biology. Looking at surface minerals and organic molecules. When we zoom in on surface minerals and organics, the rocks basically act like ancient chemical archives. Scientists scan them for microscopic structures. But here is the major trap. Extreme pressure, heat, and deep time can easily create physical patterns in rock that perfectly mimic biology. Basically, looking alike is never enough.
And what about organics? You see these headlines all the time, right? Organics found on Mars. Now, finding amino acids is super exciting, for sure, but organic molecules are ultimately just carbon-based compounds. They are the letters of a language, not the actual message itself. They're the building blocks, but finding a pile of bricks doesn't mean a house has actually been built.
It is absolutely vital to debunk a very common misconception here. Think of it this way. A pantry tells you the ingredients are there. It doesn't tell you whether anyone actually cooked a meal. Discovering chemical ingredients on an asteroid or a distant moon just means the universe has stocked the kitchen. That's it.
Let's pull this all together in Section 4, Thinking Like a Judge, the search for converging lines of evidence. To piece this massive puzzle together, scientists are looking for evidence that converges. They aren't just sitting around waiting for one magic, undeniable signal. Because honestly, with indirect evidence, that magic signal probably doesn't even exist. So they use a rigorous framework. Scientists ask 3 key questions. Is there actively maintained chemistry? Could life actually exist there? And is the pattern impossible to explain without biology? They look across the 4 clue families we've talked about, demanding that independent clues all point the exact same way. And as of right now, applying this incredibly strict framework, there are exactly 0 confirmed detections. Yep, 0. No single claim has closed the case yet. Which brings us to a really crucial takeaway for you. The next time you see a sensational clickbait article online, I want you to remember this mantra. A clue is not a conclusion, and a pattern is not proof. But a well-tested pattern, where all the boring, mundane explanations have been stripped away, that can become the very beginning of real, world-changing knowledge.
We've moved from simply asking, is there something out there, to really understanding, what would it actually take to know for sure? So I'll leave you with this final thought. When you inevitably hear the next big space discovery headline, methane found on an exoplanet, or strange organics in a meteorite, put on your scientific judge hat. Ask yourself, what else could explain this? Are multiple clues pointing the same way? Apply this framework, stay intensely curious, and keep your eyes on the stars. Thanks for joining me for this explainer.